shake it off, woohoo, hoo, hoo. All right, we're in chapter 10, lesson 3. This one is all about shapes of graphs, looking at the shape of a graph and talking about what does it look like. So our book should be open to 452, and our learning target today is going to say, I can describe and compare shapes of distributions. So we'll start with that. I can describe and compare shapes of distributions. All right, so we're looking at different shapes, and distributions is really talking about how spread out or close together our graphs are. So at the top of page 452, in the key ideas section, it's talking about some different looks that graphs can take. And it doesn't have to be just bar graphs or histograms like these ones. They can be dot plots or any other look of a graph. We're going to talk about 3 different shapes they can fall into. So the heading on this section is going to be types or shapes. We could say types or shapes of distributions. And there are 3 different shapes or types, okay? So number 1, this first one, this picture in our book here, if we draw a little graph, okay, and we have some bars, let's make some bars that kind of start low and just kind of step higher and higher and higher. And then it kind of goes like that at the end. Okay, so if you notice that this kind of travels up slowly and then it kind of drops down really quickly. We call that one a graph that is skewed left. And here's why. Do you notice that if you were looking at this, it would be kind of slowly rising and then it drops off. So most of the data is kind of pulling left. Do you see how this is kind of like a tail? We call this part here that it's kind of gradually increasing, we call that a tail. And the way that I remember it is if for some I don't know why this is kind of weird, but if this were the head of some kind of dragon or monster, this would be its tail, because normally the head of a monster you have, or a dragon, you would have kind of a long back and then a long tail, and then here are its front claws. That's kind of weird, but that's how I remember it. So the tail is on the left-hand side of the graph. So we say that it's skewed to the left. So the next graph, I'm just cracking myself up over here. Next shape. Let's make our graph kind of go step up again for a little bit. And then let's have it go down just the same way that it went up, or pretty similar. So if you look at this shape, it's gradually coming to a peak and then it's gradually going back down. If this were the head of the monster, or the dragon, right? You wouldn't really be able to tell which way the tail would be going. So in that case, we're going to call this a symmetric or symmetrical, either way, a symmetric distribution. Okay. And then our last one, you can probably guess what it's going to look like. Our bars are going to maybe start low again, but then they quickly rise. And then they slowly come back down if we were making bars. So notice how it goes, whoo, straight up, and then it slowly tapers down. So if we were to make this peak be the head of our monster again, smiley monster, here would be its front claws, and this right here would be its back and its tail. So if you notice, the tail of this dragon would be on the right-hand side. We would call this skewed right. So those are the 3 different types of different distributions we can see. We have a skewed to the left kind, a symmetric that's pretty equal on both sides. Does not be perfect, but pretty equal. And then skewed to the right. And it all depends on where that tail is of the dragon, the tail of the dragon. So let's get to example 1. We're going to look at some graphs and figure out where are they skewed, or are they skewed, and do they have a tail somewhere? So example 1 says describing the shape of distributions. So I'm going to have us go to our book. Might be easier that way. If we look at this one here, this dot plot, it's green. Okay, looks like it's going straight up and then it gradually comes down. Okay, well, let's take a look at our notes again. Straight up and gradually down matches kind of like this one. So I would say example 1, question A, we're going to say skewed to the right because it kind of looks similar to this guy. If you want to make a little picture, you can. This is a dot plot. So we had a couple of dots and a couple really tall dots. And then it was gradually kind of coming down like that. So it went up really quick and then slowly down. Question B, let's go back to our book and look at that one. Okay, question B is a histogram. Notice how it starts small, gradually increases, and then it kind of gradually decreases. It's not perfect on both sides, but you can kind of see how it gradually comes up and it similarly comes down pretty close. So we're going to call that one a symmetric graph. So let's name it first. And something important I want you guys to make sure you're drawing on this one, let's make a little X on my axis to do boxes or bars, is that when you make your bars, it doesn't have to be perfectly symmetric. So when you go up, just make sure that your bars aren't perfect on this side to show yourself that it doesn't have to be perfect. It still gradually goes up and gradually comes down. And that would be a symmetric graph. Okay, pause the video and go ahead and try on your own number 1. All right, if you tried that one, number 1 should be a skewed to the left graph. All right, hitting on example number 2 next. Let's get to that one. Example 2 is describing the shape of a distribution again. So looking at our book, the directions say the frequency table shows the ages of people watching a comedy in a theater. Display the data in a histogram, and then describe the shape of the distribution. So they've kind of given us what it looks like right here. So we've kind of done that work for us. So instead of having to plot all of this, let's just look at this picture again to make it a little easier on us. If we were to plot all of these numbers in a histogram, here is what it should look like. So you can see that it gradually rises and then it shoots down at the end. So if we go back to our notes and figure out which one that is, gradually rises and shoots down. That's going to be this one here. That's going to be a skewed to the left graph. So to write that one in our notes, let's just draw the histogram they give us, or a general version of what it looks like. It gradually rises and then it shoots down. So that one's going to be skewed left. This is described with the shape of the distribution. So that's what it does. Example 3. These ones go pretty fast when you just have to tell what the shape is. Okay, looking at our book again, let's zoom back to example 3. It says comparing shapes of distributions. The histogram shows the ages of people watching an animated movie in the same theater as example 2. So these are animated movies right here. And then example 2 was comedy movies. So here's our comedy distribution. And here is our animated movie distribution. Question A says, describe the shape of the distribution. So it shoots up and then it gradually goes down. So let's go back to our notes. Let's make that little graph. We can kind of make a general graph. Whoa, that bar got a little crazy. It shot up and then it, this is terrible, but you can get the idea. Remember, this is our animated movies. And if we go back up here, I'll try and redo my color to kind of label what this one was. This one was comedy movies. All right, go back to this question. So the shape of distribution The shape would be shoot up, gradually go down. So here's our tail of our dragon. So it's going to skew to the right. And then question B is going to ask us to compare these two, the comedies and the animated movies. Which movie has an older audience? So let's look at the ages underneath. The ages for the green one, the comedy, looks like the majority of them are right here, 26 to 29, 30 to 33. And if we look at the animated movies, looks like our common ages here are like 14 to 17, somewhere in that range. That kind of makes sense, right? Animated movies, there's going to be a younger crowd. So which movie has an older audience? Looks to me like comedies has an older audience. So question B, we're going to say comedy has an older audience. And we are done with the examples. Pause the video if you'd like to try the on your own number 2 at the bottom of page 453. Okay, so 2A just asks you to make a histogram of that. So if you made the histogram for A, you should be good. And 2B says to compare the distribution of the data to the distributions examples 2 and 3. And what can you conclude? And so you're just comparing these ones that you just created to the ones that we saw in the book that we just looked at. So not much to really talk about in terms of answers, correct or incorrect there. Okay, that is the end of lesson 3.